Now next point is packing of rigid spheres. In order to understand the packing of atoms, molecules or ions in a crystal, let us consider the packing of hard spheres of equal size in one dimension, two dimension or three dimensions. Now there are two possible arrangements if spheres are arranged in two dimensions, that is square close packing and hexagonal close packing. Square close packing, it is A type of packing, and hexagonal close packing, it is AB type of packing. So before that, just to understand, first of all you consider the close packing in one dimension. There are three axes, X, Y and Z, and suppose there is a packing of spheres along the one dimension, that is along the one axis. Say this is the X axis. Now when spheres are arranged in one dimension, then we get this type of linear arrangement of spheres or atoms. In practice, this type of arrangement is not possible in crystal. Only these spheres may be arranged in, or atoms may be arranged in two dimension or three dimension. Actually in three dimensions. But this is the one dimensional arrangement of atoms or spheres. Here coordination number of each sphere is 2. When you consider the sphere, for example this, in contact with this there are two adjacent spheres, and the coordination number means the number of adjacent atoms of any given atom or sphere. It is called as coordination number. Coordination number is 2. Now even actually this last sphere, it is also in contact with next one. Only few spheres are shown here, so coordination number is 2. And in practice this type of arrangement is not there. Just to understand the arrangement of various atoms, we are considering one dimensional arrangement. Now consider the two dimensional arrangement. So close packing in two dimensions, and already I told you there are two ways: square close packing and hexagonal close packing. This square close packing, it results in the formation, or it results due to the arrangement of spheres like AAA. So all the layers of same type. Now consider again, this is the x-axis and spheres are suppose arranged along this x-axis. So this is one dimensional arrangement. Now consider this is the y-axis, which is right angle to x. Now when we arrange the layers along this y-axis, then actually this is the xy plane. So when spheres are arranged along this xy plane, this becomes the two-dimensional arrangement. And you can look at the first layer and second layer, which are the same. So second layer is exactly aligned with the first layer. Similarly, all the layers are exactly aligned. So this type of arrangement, it is called as square close packing, and this is AAA type of arrangement. The occupied space is 52.4% and rest of the space is empty. And here this for each sphere the coordination number is 4. Now you consider any sphere, for example this, adjacent to this sphere there are 4 spheres. So 1, 2, 3 and 4. When we join the centers of these 4 spheres which are in contact with a given sphere, then it results in the formation of square, and therefore this is the square close packing. It is a square close packing. Now consider the hexagonal close packing. Again, hexagonal close packing is a result of AB type of arrangement, and again you consider the two axes x and y, and this is the xy plane, and actually plane is a two dimension. Now first of all you consider the arrangement of spheres along the x-axis. This is one dimensional arrangement. Now when we arrange the spheres along 2 dimensions. Now consider the y-axis. Now, and this is the second layer. Now, which is the different than the first? B is different than A, because spheres are not aligned. Spheres of layer B are not exactly aligned with the spheres of layer first or A, and therefore this is different arrangement and B type of arrangement. So this is A, B, again this is A, B, A, B, and so on. So this is AB type of arrangement, and it results in the formation of hexagonal close packing. Now here coordination number is 6. Why 6? Because you consider any sphere or atom adjacent to this, there are 6 other spheres. Now consider this sphere in contact with this central sphere. There are 6 spheres. So 1, 2, 3, 4, 5, and 6. Therefore coordination number is 6. And these 6 spheres are arranged with the geometry of hexagon. And therefore this is hexagonal close packing. Occupied space in hexagonal close packing is 60.4%, and it is more efficient as compared to square close packing. In square close packing, occupied space is 52.4%, whereas in hexagonal close packing, occupied space is 60.4%, and therefore it is more efficient. Now after arrangement of spheres in 2 dimensions, now consider the arrangement in 3 dimension. Now this is the, suppose this is the x-axis, this is y-axis, and this is the z-axis. Now consider 3 dimensions or 3 axes, arrangement of spheres along the 3 axes. Now this is the x-axis, and first of all we considering the A type of 3-dimensional packing of the spheres, which results in the formation of it results in the formation of hexagonal close or it results in the formation of close packed arrangement, cubic close packed arrangement. Suppose this is the spheres, these are the spheres arranged along the x-axis. So this is the direction of x-axis. Now consider arrangement along the y-axis. Now same type of layer A, it is now oriented along the xy plane. So A and A. So this is the xy plane, and same type of arrangement is done along the xy plane. As this is the plane, now in this plane spheres are arranged in 2 dimensions, that is x and y. Now consider the z-axis, that is the 3rd dimension. Now same plane, suppose behind this first layer or plane. So this is the arrangement along the z-axis or 3rd dimension. This is the 3rd layer which is just behind the 2nd, and this is the 4th layer just behind the 3rd. So in this way there is a formation of 3-dimensional arrangement. So first of all we consider the 1-dimensional arrangement, that is 1 A layer along the x-axis. Then we arranged this A layer along the y-axis, that becomes the 2-dimensional arrangement. And these planes, when we repeated along the z-axis, it becomes a 3-dimensional arrangement. Now it results in the formation of cubic arrangement. Now consider any 8 spheres in contact with each other, 1, 2, 3, 4, 5, 6, 7, 8, and when centers of these spheres are joined, there is a formation of cube, and therefore this is a simple cubic arrangement. So a type of three-dimensional packing of spheres results in the formation of simple cubic arrangement. Coordination number of each sphere is 6. When you consider any sphere in adjacent or in contact with that sphere, there are 6 spheres. For example, you consider this sphere in contact with this, there are 1, 2, 3, 4. These are the 4 spheres. So one more sphere will be in front of this, if one layer is imagined in front of this layer, and one more sphere, it is aligned backside, exactly backside of this sphere. So 4 plus 2, that is 6. Coordination number is 6, and occupied space is 52.4%. 52.4%. Now consider AB type of three-dimensional packing of spheres, and it results in the formation of hexagonal close packed arrangement. This arrangement results in the formation of hexagonal close packed structure. This is very interesting. Now consider this is A type of layer. A type of layer, and it is two-dimensional. Now consider the third dimension, that is the z-axis. Now consider this spheres of B layer. They are occupying, or they are arranged in a such a way that there is a generation of voids like this. So this is the one layer. So in this way, the spheres highlighted with blue color, these are from the A layer, and spheres highlighted with red color, these are from B layer. Now again you consider next sphere, it belongs to A type. So in this way, these are the spheres of A layer. So spheres of A layer, they are exactly above the spheres of A layer only. Okay, so, or in other word, we say that the spheres of third layer, they are exactly aligned with the spheres of first layer, and therefore this is AB type of arrangement. Again you consider this B type of layer, and this is again A type of layer. So AB type of arrangement results in the formation of hexagonal close packing. Here most important thing is, in hexagonal close packing structure, a third layer is placed over the second layer in a such a way that the spheres cover the tetrahedral holes. Or in this arrangement, alternate layers are vertically aligned or same, that is the third layer is directly above the first, and the fourth layer is thus above the second layer, and so on. Okay, now consider the A layer. This is side arrangement, this is the B layer, this is the side view, and again this is the A layer, and this is the side view. And just we join the centers of these spheres, then there is a formation of, you can see there is a formation of hexagonal arrangement. This is the hexagonal arrangement, and coordination number of each sphere is 12, and occupied space is 74%, and this is the tetrahedral hole, the empty space surrounded by 4 spheres, it is called as tetrahedral hole void, and this is the octahedral void, empty space surrounded by 6 spheres, it is called as octahedral void. So remember, AB type of three-dimensional packing results in the formation of hexagonal close packing, and it has a 74% space is occupied, and this is about the tetrahedral void and octahedral void. In detail about this we will discuss in next slide.